Today, I'm talking about the fundamental theorem of calculus. Means we will study this chapter, how to calculate the definite integral directly. As you know, in previous section, we can calculate the definite integral with the Riemann sub, not with definite integral directly. The first topic is fundamental theorem of calculus. If a function f is continuous on a and b, then let gx is integration from a to x. The upper limit is not constant, this is variable. ft dt is continuous on a comma b and differentiable on a comma b. This is x is between a and b, but not included a and b. This is also x is between a and b, and this x includes a and both a and b. So and g prime x is fx. So g prime x is why I will explain why g prime x is fx. So g prime x is limit h is approaching 0 and z x plus h minus fx gx over h. So we can calculate gx plus h minus gx. This is gx plus h is the integration from a to x plus h ft dt minus integration from a to x ft dt. The first definite integration can be written this integration from a to x ft dt plus x from x to x plus h ft dt minus integration from a to x ft dt. This definite integration is cancelled. So gx plus h minus gx, x plus h minus gx equal integration from x to x plus h ft dt. So we divided h on both sides. So this is g x plus h minus gx over h equal 1 over h integration from x to x plus h ft dt. So by extreme value theorem, extreme value theorem. What is the extreme value theorem is if some function is continuous, this function has both minimum and maximum value. So f is continuous. Since f is continuous, the function fx has both maximum and minimum value. So we can ft is both maximum and minimum. So we can it's minimum, and from this equation, take limit h is approaching 0 on both sides. So this is limit. So it means this inequality 1 over h integration x from x to x plus h ft dt is 1 over h integration x plus x plus h m dt over integration 1 over h from x to x plus h m dt. So when limit h is approaching 0, so this value and this value is approaching ft, and this value is fx, and g prime x, this is fx. So g prime x have to be fx. So this is the conclusion. So if f, we define gx as this definite integration, and if f is continuous, g prime x is fx. This is the conclusion. So take an example. Take derivative of gx equal 0 to x. Upper limit must be variable, and we derivative g prime x is the square root 1 plus t square t to x. This is square root 1 plus x square. This is the answer. This is fx integrand. So next example is, this is the upper limit x to the power of 4. So we need to apply the chain rule. So we let u equal x to the power of 4. So this is the dx integration from 1 over u sec t dt. So this is we firstly, and with the derivative with respect to u sec t dt and du over dx. So this is du over dx multiply. This is sec u. So we let u is x to the power of 4. So it can be d dx over u is x to the power of 4 sec x to the power of 4. This is 4x cubic multiply sec x to the power of 4. This is the answer. And next topic is fundamental theorem of calculus. If f is continuous on a and b and integration from a to b fx dx is fb and fa, where large f is antiderivative of fx, if we know antiderivative of integrand, we can calculate definite integral directly. So this is continuous. So we let gx be integration from a to x fx dx, and it means gx is integral from a to x fx dx. Some antiderivative of small fx is large fx is gx plus c on a and b. So fa is ga plus c, fb is gb plus c. So we subtract from this, and this is fa minus fb. B equal ga minus gb. This is ga is integration from a to a fx dx minus integration a to b fx dx. Correct? This is a integration a and b, and c is cancelled. Large fa minus large fb equals ga minus gb. So this is minus integration a and b fx dx. So our purpose is to find this definite integration. The definite integration is integration from a to b fx dx is fb minus fa. This is a very important conclusion. We have already known in high schools, but this is very important. So we don't need to change definite integral into Riemann sum in order to calculate this definite integration. So if we only know the antiderivative of small fx, we can calculate the definite integration. This is the conclusion. So evaluate integration from minus 2 to 1 x cubic dx. In previous section, we have to change this definite integration into Riemann sum, and we calculate the Riemann sum, or we grab this function and we calculate the area between this function and x-axis from minus to 1. So we don't need to this process if we know calculation, direct calculation for definite integral. So antiderivative of x cubic is 1 over 4 x to the power of 4. So this is 4 x to the power of 4. It is antiderivative of x cubic from minus 2 to 1. It's b, and 1 multiply 1 to the power of 4 minus 1 over 4 multiply minus 2 to the power of 4. 1 over 4 minus 16 over 4. This is minus 15 over 4. Very, very simple. The calculation for definite integration become very simple. We don't need to change Riemann sum or area. So next example is find the area under y equals x squared on 0 to 1. So this is definite integration between the integrand and x-axis from 0 to 1. This is the area under y equals x squared. So it means that we x and y and 0 to 1, and we want to find this area. We don't need to change Riemann sum or try to find this area. Just we definite integration is enough. So antiderivative of x squared is 1 over 3 x cubic from 0 to 1. This 0 to 1 means x equals 0 to x equals 1, and 1 over 3, and b is input. 1 cubic minus 1 over 3, 0 cubic. This is 1 over 3. The area is 1 over 3. Very, very simple. So we try to find this integration. This integration is the area between 1 over x squared and the x in the x-axis from x equals minus 1 to 3. So x squared, this is x and y 0. X squared is like this. This is minus 1 over 3. This area. On the graph, we cannot find this area because this is infinite. But however, we can calculate this integration, but not discuss it here. We discuss this kind of integration later. So from now, we cannot calculate this integration at this chapter, and this chapter later. We will discuss this later. So this is antiderivative of 1 over x squared is minus 1 over. This is minus 2 over. Antiderivative is antiderivative x to the power of minus 2 is minus 2 plus 1 over 1 x minus 2 plus 1 is minus 1 over x. This is definite integration is minus 1 over x 3 minus 1 over 3 minus 1 over minus 1. This is minus 1 over 3 plus 1 minus 2 over 3. This is long. This is long because we have discontinuity at x equals 0. If we have the point which is not continuous or not differentiable, we take another method to find this definite integration, but not discussed now. But we will discuss this later. So today we discuss this chapter, how to calculate definite integration directly. Thanks for listening to this video, and see you next time. Bye bye.